and it's also exciting to me here. So, dear members of PAGEV, thanks first of all for the invitation, and then let me introduce you to that wonderful world of polystyrene. And if you can pass the clicker on, then I can also...
Kumandayı alabilir miyiz?
Yeah. So, yeah, I'm happy to talk about polystyrene a bit. Yeah. We already heard about PET and the polyolefins, and actually polystyrene is the next material in the chain now. And the wonderful thing about polystyrene is sometimes it even excels over the big polymers like polyolefins or PET. And one aspect of that is the recyclability. Now, what I want to show you here today is how we brought polystyrene even back into food contact as a recyclate. That you know that this is possible, that should be maybe the take home, but we'll see. So why do we use polystyrene at all in dairy packaging? Why is not everything made out of polyolefins or PET? I think the key is polystyrene is the fastest material to process. So if ever you talk to a producer or a converter who produces foils or the producer who produces yogurt pots, for example, then the fastest machine running is the one with polystyrene, by far, 20–30% faster than polyolefins, for example. It's also easier to process, so it's very, you will not see that much of scrap, and the processing window is quite large because it's amorphous and does not have a specific melting point. And then if you think about the big yogurt pot multi-packs, then it's, for us as a consumer, it's the easiest to break. That's not something that you will find with polyolefins, or you need to perforate it and really make difficult efforts to bring it to that level. So that's why we use polystyrene in dairy packaging. And, well, as it is mainly used in food packaging, we also had the challenge to recycle it back to food packaging. So we made it. It is introduced into the supermarkets already. Quite a challenge also with the already cited new regulation, the 2022-1616, but it's all in line, so regulatory, it's fine. If I have time, I'll show you. In this pot that you see here on screen, it is recycled and incorporated at 30%. So basically, that's not yet limited, but we don't want to push it too high because we want to serve multiple customers, and we don't want it to be too low because it should be significant also. So the recycling technologies we have are different circles. Now, so the smallest circle is the mechanical recycling one, as already mentioned for the other materials as well. The depolymerization thing is something, we hear it also in PET. Actually, in polystyrene, it works thermally, so you heat up polystyrene and it decomposes into the monomer. That's quite unique because it avoids going back to the steam cracker and doing everything what you have to do for pyrolysis, which is the largest cycle. Maybe you should also look on the top, that renewable feedstock introduction. This is the bio pathway. You know? So if you think about used cooking oil, you can bring that into the steam cracker, and then you can have bio-attributed content. Good. The mechanical recycling is basically what you think about how recycling should work. No? So you have the bales, you sort the bales, you try to take the colored materials out, you try to take the non-food materials out, then you wash that hot because it needs to be clean, you sort it again on the level of flakes, and then you end up with a granulate, which you then introduce into a process which we call super cleaning, but which is also known from PET. So you extract everything that could contaminate the plastic. And this is actually the way how you bring it back to the yogurt cup. Same, so you basically start from a food contact item, from a yogurt cup, you do the circle, and you end up in a yogurt cup. Why does that work? Well, this is with PET the same with polystyrene. Any contaminant has really difficulty to enter into polystyrene whenever it is in the waste bin or so. And if ever it enters, it really has again a difficulty to find the way out, especially if it's in a chilled application like a yogurt. So this is the secret, and this is the different behavior to polyolefins. So polyolefins absorb really easily all kinds of contaminations, and they also release them quite easy. So PET and polystyrene are quite unique on that. So this is just the background. It's a material property. It's nothing that we have invented. It's just like this. Of course, we have done intensive testing, no? So you need to think about the migration, you need to think about which color will the consumer be accepting, can we do the same print quality, can we process it the same, how is it behaving in transport, will the yogurts break, whatever, no? So all this has been done, and we have introduced them then to the market. On the regulatory side, I'll be really quick. So you have to measure a lot, and you have to report it to the authorities every 6 months. We have done this 5 times now, and we ask for the official EFSA opinion, and this is an ongoing process, so we expect it actually, well, next year, I would say. The other way was the depolymerization. So depolymerization is a kind of chemical recycling, and this, just that you know, also exists at scale. So since September, Indeva has inaugurated a capacity of 26,000 tons, where they take polystyrene as an input material and produce styrene. And the styrene then is transported to us, and we can use it again in the polymerization. So that one was at the origin of bringing a polystyrene article back to food. Everybody said that would be the unique possibility. Well, it's a perfect possibility, but it is complementary added by the mechanical recycling that I just introduced to you. But also this one here is existing. The advantage and why it's a synergy actually is that you can use different raw materials. So you could use foam, you can use those trays that I've put here as an example. And you can also produce different materials. So you can easily produce a medical article, like a Petri dish, or you can use different polymers even, like ABS or ASA. All this can be done with that styrene, which we get from depolymerization. A quick one on footprint, because everybody talks about footprint. So what is a footprint? Well, first of all, it's the thing that we leave behind, and we can recognize. So a dog can be a dog, a horse can be a horse. And sometimes on the beach, I think this is the footprint of idiots. But this is human behavior, no? So, and the question is, how can we tackle that? And one thing is, of course, education, but that takes a long time, and we might not have that time. Another way to tackle this is to put money on it and kind of deposit, and then this will disappear relatively quickly. If we talk then about footprint of polymers, then we talk always about carbon footprint. So if we consider the carbon footprint, then the recycled materials are all much better off than the virgin. If you think about the bioattribution, the used cooking oil example, then it can be even negative. Mechanically recycled, it will save about 60%. Chemically recycled depolymerization, it will save about 40% of the footprint, which we have seen in virgin. So that is only a quick summary, because you paid a lot of attention. I'll spare that one. And thank you for the attention. And I'm happy then if later on we have a lot of questions.